In this video, I'm going to demonstrate how we can develop Uniface service components, test them in a development environment, and deploy them for remote execution. First, we should look at the runtime architecture that underlines this type of remote deployment. We start off with a typical runtime environment for an application, Uniface clients running Uniface.exe in their own workstations dotted all over a network. They would, in a fat client situation, run their services locally there as well. When they're deployed remotely, they will execute on an application server which runs a Uniface URouter process to direct requests for activation of remote components to a pool of one or more Uniface application servers or userver.exe. For the purposes of this demonstration, I will bring the Uniface client into the environment of the actual server by looping back the calls to the Uniface server on the same machine. The Uniface client environment would also, in this case, be the Uniface development environment. Now we should look at the types of components that are actually supported for remote deployment. Uniface report and service components, as introduced in Uniface 7, are available for remote deployment. So are also session services, which are a part of the three-tier architecture introduced in Uniface 8. Basically, any type of component that doesn't have a Uniface GUI or structure editor interaction is deployable for remote work. Some design considerations we should discuss are the fact that service components should be self-contained. That is, they have no dependencies or references to global variables or other types of global objects. It's also highly desirable that the service components are stateless with regards to how they're activated from the client. When you consider that the Uniface server process is a shared serializable process by default, you can then understand that a request or multiple requests from the same client could be directed by the URouter on a remote server to more than one, or certainly a different U server than was used last time that client spoke to the server. Likewise, in particular U server that's being managed by URouter is handling multiple requests from different clients across the network. Hence, stateless is the best way and only practical way to architect this type of interaction. Synchronous or asynchronous activation from the client to the server are both supported. If you have services that are stateful with their clients, then they can be deployed in the Uniface 8 and 9 environment by implementing the old behavior of Uniface 7, whereby the server is exclusive to each particular client session. That means it can't be shared. That means you don't gain any benefits from scalability and reduction of memory usage on the server. However, for compatibility reasons, this may be useful in some situations. In this demonstration that follows, I'll be showing a form component called maddress with a simple address entity and a foreign key painted, and its purpose, and then we have an activate of a country SVC component, and its purpose is to retrieve a val rep for putting in that address foreign key. Country SVC has the country entity painted and just one output parameter in its sole operation. Thus, it is possible to call it statelessly and for it to be called asynchronously. First thing is, after you've developed your service, you want to test it in the existing non-remotely deployed environment just to make sure everything's working okay. This will be evidenced in our demonstration of the fact that both the country svc.svc file and the maddress.frm file are both residing in the development, or being opened and run from the development environment. So to actually deploy country SVC remotely, there are three areas to look at. First of all, the urouter.asn file running on the remote server has to have an entry for the particular server it needs to start up. And here you'll find under the servers section a UST name called myserver. It will point to the executable for userver. There'll be a working directory or folder through this environment, and notice in this case, even though it's on the same machine, it is in fact a deployment folder, and of course an assignment file. The /dnp parameter is generally optional, but should you find some unusual problems in testing this type of deployment in your environment, and this may be evidenced by -25 return codes in a urouter log file, then you can add this /dnp equals TCP : the literal name of your local host, or sorry, that remote host name, plus the port it's listening on, 13001. Right, so with that configuration set up, the way to actually deploy a service component is to edit the client's or application's runtime in an assignment file and add a section called services exec. Beneath that you would list the services that are to be remotely deployed. In this case I've used the specific name country SVC and I've assigned it to a path $TCP SVC. Now note that I've done that one particular service name, but you can use wildcards in the same way that you do for files and entity sections of the assignment file. In the paths area there will be a new path definition, $TCP SVC, and as you see it goes across the network to the remote host name. In my case, for this demonstration, it will be of course this same machine, and I tell it to go to port 13001 where the urouter is listening, log on to that server, and I mention the UST name. Obviously this has to match with the service name and definition underneath that. Now as we know, the /asn file there is referred to as my server.asn. All we need then to complete the remote deployment is for that assignment file or that userver to know through the file section where is the actual component located. And as you note here, of course, it is the deployment folder. When we run a test, we'll be able to see that the client-side log file will show the maddress.frm being created, or a reference to that file in the development folder. And then instead of finding a reference to the country svc.svc file, there is in fact a checkout of a license option, ucltsrv, indicating that it's going across the network to resolve that reference. The existence of a server file indicates that the server is started. You can see the file references to userver.aps and indeed of course the country svc.svc file in the deployment folder to simulate a remote deployment. In addition, there is a license reference to a feature called USRV SVC. Please see the Part 2 video to see a demonstration of remote deployment of services.